So when I have to use the external table, then the whole life cycle of which we are going to analyze the data, it depends upon Hive only. There is no external applications involved in that analyzing purpose. So at that time you have to use the internal table. But I know for the external table, when I know there is some other team as well who is using my data which I am analyzing. Like you can take an example. If I am ETL developer of Hive, I create the table, I load the data, and I have to go for analyzing purpose. But the thing is, there is some other BI team, like business intelligence team, like you can take an example like visualization team. Okay, visualization purpose, they are using Tableau. One of the software is that. So they are connecting that Tableau to our Hive server. So they are analyzing the data from our tables only. Okay. So as we know, if we drop the external table, the data still remains there. Okay, it will not impact to the other teams. It will impact to mine only. It means we have to drop the structure of the table, not the data. If I use the internal table and I delete the date, drop the table, and some other external thing will be connected there, so it impact with the external team because the data also deleted from there. So it's like that. If there is a hierarchical process, hierarchical teams are there. So at that situation, you have to use the external table. If there is no external teams are there, only it depends upon the whole life cycle of the Hive only, you have to go for internal table. So this is the main difference between that. You have to take the decision as per the requirements. So hopefully you understood these concepts of when I have to use the internal table, when I have to use the external table. Okay, so fine. So now coming back to our topics, which I am going to discuss for today. So how to alter the table in Hive? Like just I have a requirement. First one is rename. Rename means to change the table name. Okay, so how we can do this? Change, like to change or modify a specific column schema. Okay, so we have to replace means replace all schema and with new schema, you can say. Okay, add column means we have add new columns, add new columns. Yeah, add new columns or schema, we can say like that. So how we can do, how we can achieve this type of uh, altering the tables, so we'll see in the practical sessions. Now coming back to our Cloudera. So this is my home screen. So you have to minimize it first. Go to open terminal here. Go to Hive. Okay, it's opening Hive. So meanwhile, there is a data space. ls cd partition ls. Okay, so these are the data sets which will use the latter for packaging and partitioning. So now the Hive terminal is opening, so we are waiting for that. Let's see. Meanwhile, I can open this one. This is a legacy which we have. If you want to see the home directory of the HDFS, you can go here and you can see all the directories here. And meanwhile, the Hive is starting. It is taking some time. Okay, so so let me write the command first here. Okay, so for this, like how to change the column, so the command which we are writing here, alter Okay, alter, you have to give table, and whatever the table name should be there, initial table name which you are going to change, and you have to give rename. Okay, to new table name, means to which you have just changing the table name here. So this is the first one you should have to first change we are talking about. So alter table, and you have to give the table name here, and after that you have to change the specific columns. So whatever the columns you're going to change, you have to give the first column here, columns with data type. What about the data type with has? So you have to give sorry, columns here, columns name you should have to give, and whatever the columns you are just going to change with name and like that. So new column we can say, new column name and with data type. So here the data type should be here. So we'll see in the practical as well. Now coming to replace columns. So how to replace the column? Alter table, table name in here, and you have to give the replace columns. Okay, and whatever the columns you're going to replace, you have to give here new schema. Well, new schema means to replace all that schema with new schema here. Now I have the requirement like I just want to add a new columns in the table, exist tables, alter table, table name. Okay, so after this, what add columns, and whatever the columns you are adding here, you have to give columns, columns, new columns value, columns name with data type. Okay, you can give 1 2 3 like that, anyone. Okay, so it will accept it. So these are the way we can go ahead. So let me go ahead with these things that have already started. Okay, so now it's fine. So show databases first. So yesterday we have created some tables like internal table, external table. So we'll discuss, and we have created one of the tables here, and we'll see. So right now in batch 2, okay, so use the batch 2, one of the databases there. So now show tables. There is no tables right now. So I'm just going to create one of the tables as per the schema. So I can take any data here like partition data. So what is the data here? Sorry for that, partition data. So there is the data like one Sunny SC 2009. So these are the employees data which we have. So one is the ID, name, department, and year of joining. These are the schema which we have. So let me create a table here. Create table if not exist. Okay, if not exist, table name. So table name I'm giving test. Okay, so what you have to give schema here like M ID, which should be integer, M name, employee name, we can say, which should be string, and there is a department and year of joining. So we can say M department, we can say DPT, which should be string also, and year of joining by OJ, we can say it should be in integer. Okay, so now coming to row format delimited, because it is delimited with some of the columns. Okay, fields terminated by. So how the fields is terminated here? With comma. You can see here the fields is terminated by comma here. Okay, so now coming back, lines terminated by line here, and we are storing the file as a text file, stored as text file. If you will not give this stored as text file, by default it will store as a text file. As you know, text file is a default file format. Okay, so now let me go ahead and we'll see. Okay, now it's the table has been created. Show tables we can give here. So now the table is there, as we can see. So how to check the table structure? We have to give row this tab formatted. and test. So we can able to see the structures of this table. You can able to see the like this is the schema, this is the database which we are using, this is the user. By this user only we have created this database and tables, and these are the structures, or we can see these are the storage area where the table has been created, like user by Hive warehouse. These are a directory, inside that the database is there, and inside that the table is there. So it is a kind of managed table because we have not used any external keywords here, and these are the delimiter which we are using as a field terminated by like that. So now my requirement is, first we have to change the rename the table name from test to demo underscore test. First requirement like that. So how to do this? Alter table name. First is my table. Now I just want to rename to demo underscore test. Okay. So I just want to like that. So let me enter. So now I can see that show tables. Initially it is test, now it becomes the demo underscore test. So the first requirement has been completed. Okay, it's the called rename. So now coming to the change. So as we know, if we go ahead describe demo underscore test, I can give like that. So we'll see the structures of a schema: employee ID, employee name, employee department, and YOJ. I just want, okay, instead of employee department, I just want okay, instead of YOJ, I just want to year of joining. I just want to write year of joining in whole, and instead of the integer, I just want to big int. So how we can do these things? So let me go ahead, alter table, and you have to give table name here. So you have to give change what YOJ. Okay, you are changing to YOJ. One of the column is there, schema level, and you have to give year underscore of underscore joining. Okay, and you have to give comma. Okay, big int. Okay, not comma here. Here is to be big int here. You see. So now again, if I give describe, we'll see here. Instead of YOJ, I am just, it is now year of joining, and instead of integer, now it becomes big int. So like that, for the existing table, I can change, I can alter the table here. So now the next requirement which we have, can go ahead with this. Okay, next one is replace the whole columns. Okay, and I want to add some columns there. So how we can do that? So let me go ahead. So right now it is M ID, M name, M department. So I don't want any more M. It should not be like that. So how we can change it? Okay, so I just want to remove all M from here. Just want ID, name, department, year of joining, like that. Okay, so how we can do these things? Alter table, table name. So what is the table name here? Demo underscore test here. Okay, so you have to give replace column. Okay, and instead of M, I am giving ID and name string. Okay, department string. Okay, instead of year of joining in the caps, I am just adding YOJ. It should be in big ink only. Okay, so let me write it here and give enter. So if you go ahead again, describe here, you can able to see, instead of emp id, it is id. It becomes now, instead of emp name, it becomes name, department, year of joining. So now I have changed all the schemas from that table. So this is the way I can change the schema. Now coming back to add one columns in the existing table. So how we can add? So like initially, if I describe it, there is no more salary columns is here. So I just want to add a salary column. How we can do these things? Alter table, table name, add columns. I just want to add one columns. What is that? How we can do? Select salary. Okay, it should be in begin or float like that or double like that. You can use it there. Okay, so somewhere, okay, columns spelling I have done mistake. Okay, alright. Columns, yeah. Anymore, it's okay now. Add columns. Yeah, it should be fine now. So now I can check if we describe this again. So initially I have not, till here I have the schema. Now it becomes salary, one more column here. If I want, I can add more and more schemas information here. So now we have seen till how to alter the tables in Hive, like how to rename, how to change the specific columns, how to replace whole columns, how to add one columns there. So till we have discussed about these things. Now coming to one of the most important topic in Hive, like that is a partitioning. So just discuss about somewhat what is partitioning, then we'll go for the practical sessions. So like take an example. I have one tables of employee. Okay, in a company every year, thousand of 10,000 employees. Take an example, 10,000 of employees every year they join. Okay, in a company. So there's every year means from last 50 years there are around 50 lakhs of employees should be there around. Maybe it may be like that. Take an example. So the whole records is stored into a single table. So what happened? The whole record is shown in a single table. So what happened in the real-time scenario when they just want to analyze the data? So it will take a lots of time because in a single table they just scan as per the record. Like I'm just saying, so I just want the data who joined. Just want the employee data who joined in 2010. So what is happening? I just give the condition like this: select star from employee. Suppose employee is one of the table, and where year of joining is equal to 2010. I just given like that. It will give the results. Okay, whatever the time it will take, I'm not worrying about time till now. Okay, it will take some time. It will give the results. But what happened internally, it will scan whole data, whole records in table in real-time scenario because the whole records of the employee records is stored in a single table only. Is stored in a single table. That's what whenever I give this condition in RTBMS also, it will take it will scan whole data because it may be like that. It will go for one records. It will check what is the year of joining there. Okay, if it is about 2010, 2010, it will put somewhere. Okay, in array will be created there. It will scan the another record, second record, third record, like that. If it is a 50 record, 50 lakhs record or millions of records, so they will scan whole millions of records. So it will take a lots of time. As you know, HDFS is a sequential sequential file accessing method. File accessing, we can say. So HDFS, what data we are storing? The HDFS, if we are going to access the data, so we can able to access the data in a sequence wise, 1, 2, 3, 4, 5, like that. It is not random access. So that's why it is taking a huge amount of time. So how we can avoid this? So like take an example. Now I'm just it is suppose it's taking a lot of time around 1 30 minutes. Okay, take an example. It's taking 30 minutes because we are dealing with not 10 records to 20 records. We are dealing with petabyte of records. So here petabyte of data. Here you can say crores of records you are dealing at a time. So it will take around that. It is a minimum time saying it may be like a 1 hour, 2 hours time it will take. So what is the performance here? It is degrade. The performance degrade here without partitioning because we are accessing from one of the tables only. So what we are doing in partitioning, we just partition the tables data in a specific column. A specific column. So as I have told you, we have the employees data. Every year the 10,000 employees are coming in a one company. So every year the 10,000 employees are increasing. The 10,000 records increasing in that tables. What are the single tables they are using? So what we are doing? Can we just partition this data on a year wise? Yes, we can do. So like year is equal to 2010. Year is equal to 2011. So whoever the employee comes join to 2010, his records will be in this directory. Okay, so it creates a directory internally. Okay, and who will join in 2011, it will also create a directory. So like that, year 2012 we can say. Okay, so it will also create a directory there in a single tables only. It will create a directory like partition we are saying. So what happened if I give this command? Okay, understand. Select star from employee, one of the table where where year is equal to 2010. I just want whoever joined in 2010. So what happened, it will match. Okay, this table is partition or not. Okay, if this table is partition, that employee table is partition, to which that is partitioned with columns year. So the year 2000, if I give, it will directly go to this directory only, and it will just check whole is, it will scan whole data, and it will give the, it will retrieve the data and give the output to us. Okay, so what is happening here, it will not go for 2011 data, 2012 data, or it will not go for the earlier data as well. It will directly search year is equal 2010, it will go there and give the data directly without scanning the whole data. So without scanning the whole data, we are just reducing a lots of execution times here. So that's why we are going ahead for the partitioning concepts here for performance tuning purpose in Hive. So I hopefully you understood the concept about the partitioning. So you can say instead of storing in a single table, we can just partition that table's data into some of the conditions of columns, related columns. Okay, like year or employee or like that you can say. So as per the columns, you can just partition that data and you can retrieve the data within the less execution of time. So it will be a keep a better performance as compared to the single tables data which are stored, which we are doing right now. So that's the main reason we are using the partitioning here. So in partitioning also, there are two types of partitioning here. One is the static partitioning. Let me come back. So what is the static partitioning here? So first, how to create the partition table. So we'll discuss about that first. I'll try to understand what is static partitioning. So static partitioning is nothing. Are we are the responsible to partition the data each and every columns. Like I told you, year is equal to 2010. Okay, so sorry, year is equal to 2010. First we have to load the data who is joined in 2010. Next I have given, no, again we have to load the data who is joined to 2011. Okay, so again we have to load the data, means we are the responsible here to load whole data whose year wise. So if we have the year like 2020 from 2010, so we have to load, we have to trigger these commands. I will tell you what were the commands to load into the partitioning. So that commands will be triggered 10 times by the developer here. So there is a static, means I know to which column we are going to partition and how many times I have to trigger this to load that data. So as per the year. So this is the static, because everything is static, there is no dynamic. So what is dynamic here? So we are not doing like this, whatever we have done in the static, like years ago to 2010, 2011, 2012. So what we are doing, we are just going ahead to load whole data into the partitions in a single shot. In a single shot, we load the data in partition. Okay, so like that we can say in a single shot, not the 1 2 3 like that. It will not work like that. So we will see how it will work. So coming back to static partitioning, what is the syntax to create the partitioning and how to load the data into the partitioning tables here. So the syntax for creating the partitioning is below. Let me write here: create table, you have to give table name, okay, and you have to give schema definition, okay, and there is a partition column should be here, for which you are going to partition the tables. So you have to give columns with data type, okay, else you have to give the same thing, row format delimited, and fields terminated by delimiter here. Lines terminated by, also we are using delimiters and delimiter here. Okay, so this is the syntax which we are describing you, is stored as text file. So we are dealing with text file right now. So this is the way I can create the partition table. Okay, so it's like it work for external, it work for static partitions, and this command is work for dynamic also. So we'll see about the dynamic later, about the static. So now after creation of this table, how to load data into static partition table. Okay, so how to load the data, what is the concept stack? So as we know, in Hive internal external table, we are using one of the command load data local. Okay, we have to give in path, like path here. Okay, so after this, into which table you are going to load, table name here. Okay, so that is fine. Now coming to partition, because this is a partition anymore, so you have to give partition, and you have to give column name is equal to value. What is the value? You are just going ahead to partition that table. So like that, I told you, like column is equal to YOJ, year of joining, is equal to 2009. So whatever the, if I give like this, so it will just partition the data. Whoever joined in 2009, it will create a directory there. YOJ is equal to 2009, and in that directory only the 2009 data, whoever joined in the 2009, that records will be there. That employee records should be there. If I know there is a 2010 record as well, so I have to just go ahead with this, and instead of 2009, I have to give 2010. So like that, we have to write every time this query. Okay, 2011, 2012. So like that, this is the way how the static partitioning works here. Okay, so but it is not a good way, right? If there is a around uh, thousand of the records which we are going to partition, it will get around thousand of the partition data. So it is not a good way to write these type of queries there, and it will work. It will not work at that time. So that's why everyone is using right now dynamic partitioning here. So dynamic partitioning, how the table, whatever we are creating here, syntax for the table, it is same. There is no difference. Okay, in dynamic, but there's a little bit difference. What I will tell you about that. So and the loading file as well is same. Okay. No, loading file is different here. Okay. So let me write it here. What about the loading here? So load data into dynamic partitioning. So I hopefully you will get confused here. I know. So I will discuss what about the confusion you will get here. Insert override. Okay. Table name. Okay. Give partition. We have to give columns, column name. Okay. Columns name. Okay. Okay. We can give columns name. Select. Start from temp underscore tab table. So you have a questions like initially in static we are using the load data local. This is the way I can go ahead to load the data. That is fine. This is the static way of loading the data. But why you are using insert, override, table name, partitions, column name, select star? So where I can get this? The first question you should ask, where I can get this data table? Okay, temp table. Why, from where? Means I haven't created any temp tables here till now. So how I can use this? What is the data there? What is the structure for this temp level? So we'll discuss that thing. Before that, what is the meaning of override? Override means we have to override the data. Means whatever the data existing in the tables, we have to delete that records, and we have to just override the data as a new records. That is the meaning of overrides here. So now coming, because we know in dynamic partitioning we have to load data into single shots only. So for that you have to worry about one more concept, one more table, that is known as temp underscore table. So you have to create the temp table. Okay, so how to create table if not exist, and you have to give the temp underscore table name. Anywhere you have to give temp table name with schema definition. Schema definition means whatever the data you are going to load, first you have to load in any temp table. That is the main motto here which we are doing. Row format, yeah, row format delimited, and fields terminated by the delimiter you have to use here. Okay, that is fine. And now coming back to lines terminated by, you have to use the delimiter also here. And how you're going to store this file is stored as text file. Okay, so this is the way we can create the tables, like a temp table's name. And after creation of this table, you have to load data into temp table. So I will show you this whole thing, this whole concept as a practical, so you will be aware of these things. So how to load data, you know, right? Load data local, because we are dealing with the local file systems data only. If the data is on HDFS, so no need to worry about to use this local keywords. So local in path you have to give, and this is the path. This is the path you have to give. Whatever the path into table and temp table name. Okay, temp table, whatever the name you are mentioning there, you have to give. So after loading the data into temp table, you have to run this query for dynamic partitioning. What happened internally? It will create the all partitions data into a single source. No need to write this type of commands anymore in dynamic partitions. So what happened? It will save your efforts. It is a smart work. So this is the way you have to use the partitioning here. So now come back and take the example with the practical session, so you will understand about the partitioning more. Yeah. So I am taking the data sets like partition data only. So we have the partition data like this. Okay, so let me enter some more data here. So it will be better to partition it. So instead of 4, we have give 5, ABC, SC we can say, and 2010, okay. And we can give 6, DAF, anyone name like that. We have to give HR department. He also joined in 2011. So like that, I am just giving like 7, DFG, and give like TP department, and it joined on 2011 only. So this is the 7 records which we have. I'm going to partition it. Okay, it is a taken example. I'm just taking example. So let me save it. Yeah. So now coming back partitions. So with this which have data we have, I'm just going to partition this. So what we have to go to use dynamic partitions. I'm going to use it. So before going to dynamic partitions, before creating the dynamic tables, partition table, we have to create a temp table first. So I'm using the bash2 database as we know. So is there any tables here? Yeah, I have a demo test. Okay, so no problem. Leave it at that table. I'm just creating a demo table. Create table if not exists. You have to give temp underscore tab. I'm giving the table name like that, temp underscore tab. And what is the schema which we have? ID, name, department, and year of joining. ID integer, name string, department also string here, and what is that? The last one? Yeah, year of joining. So YOJ is sorry, YOJ is equal to, we can say int only. It is a 4-digit. That should be fine. That will work here. Okay. So format delimiter. Okay. So fields terminated by, all the fields terminated by here. You can able to see it is comma separation, right? It is a comma. So fields terminated by comma here. You can give comma, and lines terminated by, how the lines is terminated here, new line. Okay, whatever the lines, it will new line, it will give for the another records, and we are storing the data as a text file. Yeah. So let me go back. It had the table has been executed. How click is it created and show tables. Now I can give table here. So now what my first requirement is I have to load this data. I have to load these four records into the temp table first. So load data local in path. You have to give the path here because from where we are loading pwd, that means present working directory. You have to copy and you have to paste it here. And but we have to give the file name because in that directory there are multiple files are there, bucketing file and partitioning data. So we are dealing with partitioning.data only. So let me copy this, and before paste you have to give slash here and paste it here into table, and table name is anymore temp underscore tab. Okay, so now the data is loading. Now it has loaded successfully. It's taking 5.835 seconds right now. So let me select stuff from temp underscore tab. Okay, so anymore I can see the 7 records here. You can also see this is the 7 records, page 7 records. The data has also 7 records here, so everything is okay. So now coming to create a dynamic tables, dynamic partitions tables here. So let me create table. If not exist, I'm giving dyne underscore tab. Dyne stands for, okay, let me give the full name here so it will not be confused. Dynamic underscore tab. And one more thing, we are going to partition the data on the base of year of joining. We are going to partition the data on the base of year of joining columns. So whatever your partitions column there, you should not mention in the schema there. Okay, so don't be confused. ID integer, ID is there, ID integer, name string, and department string also. We are, as I told you, we are going to partition with year of joining, so we have not mentioned any more in the schema because that columns which we are going to partition, it will be defined in the partition by one of the keywords which we'll use right now. So let me enter. We have to use partition because we are going to partition our table, partition by. Okay, what is the columns we are going to partition? Year of joining, YOJ. Okay, so YOJ, that is integer. Okay, data type we have to give, and it has completed. You have to same as it is, row format delimited, fields terminated by. Okay, fields terminated by, what is the field termination here? Comma here, and lines terminated by this is stored as text file. Okay, so let me enter. So a table has been created, that partition tables. Now you can able to see dynamic tab completed. So I can able to see the whole records in this table, temp table. So as per the performance, this will not give the better performance. So that's why I just want to create a partitions table. I just want to what I'm trying to say, I just want to partition the data in terms of year of joining. So what I have to do, how to load the data, insert. Okay, insert, override. Okay, table. You have to give table name dynamic underscore tab. Okay, so you have to give dynamic underscore tab here, and what we have to give partitions. What partitions? Partitions by YOJ. I have said told you. Okay, so after that, what you have to do, select start from temp underscore tab as I have told you, there is a temporary table where the data is loaded there, right? So insert override table name. I have given the partition by YOJ. Select happen this table. So let me enter. It will throw an error, not an error. It will be a some value need to be set up. So what is saying? Semantic exception error. Dynamic partition is strict mode requires at least one static partition column. To turn these off, set hive dot execute the dynamic set partition. So you have to set these arguments or this value we can say. So copy this and paste it here. Okay, anymore I have forgot to set. Yeah. So column here. So now it's set. Now you can give this command one more. So there is a job triggered here. The job has been triggered. So now let me go ahead. I have created a table in user inside a hive and warehouse. There's a batch2.db. There is a dynamic tab. So I have the table temp. You can see here inside the partition data. The data all over the data is here only. So now coming back and see the dynamic table. So it is creating a staging hive table. So what is happening there? The data is still loading. So if the job is already triggered, it will take some time and it will execute it and it will just partition the data as per the year of joining. So I hopefully it will create one, two, and three partitions. Okay, three files, three directories should be created here. Okay, so just wait for some time. It will execute the job and we'll get the as expected results. Okay, so these are all about the partitioning we have discussed till now. After this, there is one more concept here, bucketing. So bucketing is like also a performance tuning in Hive. So what is the use of bucketing here? Is also a slice mechanism. We are just breaking the data. We are just party means breaking the data into the slices. So it's also performance tuning we can say. So let me write about something about the partitioning here. Bucketing. Okay. So bucketing is one of the data slicing mechanism. Okay, in Hive along with partitioning. So if someone asks you, bucketing, can I use the bucketing with partitioning? Exactly. We can go ahead and use the bucketing with partitioning. Okay. I can also use the bucketing individually. Individually, I can use it. And with partitioning also, we can use it, that bucketing. Okay. So this is the way we will use bucketing for table sampling. Okay, so we'll talk about these things, what is table sampling and all, when we'll discuss about the practical session. Table sampling. Okay, so it's like a range. Okay, so where am I? Yeah, select a range of data. So we are just selecting a range of the data here. So whenever we are from Hive, so whenever we'll just talk about the like we can say in practical sessions, so we'll talk about this, what is data slicing mechanism, how we can use the bucketing here. So these all information we'll see in the practical sessions. So it will be very clear on that because if I told you about the theoretical parts, it will not be clear for you. So let me go ahead with that job. So what about the resultant? So that job has been completed. Okay, so you'll see one file, two files, and three files has been created. Okay, and you can see loading partition with year of joining 2009, year of joining 2010, year of joining 2011. So let me write go ahead here, and I can able to see these three directories has been created in 2009. The whoever the joined 2000, that data should be here. So it is a bucketing file. The data is here like first Sunny, second Animesh. So let me go ahead with our data. Is it correct data or not? So in 2009 only two records are there. Sunny and animation. I can see here, right? Sunny and animation. So it's the data which we are getting as a partitions. It's everything is okay. Now coming to 2010, what about the 2010 data? So as I have seen, 345 is from 2010. So let me check. 345, the data is there. It is becoming 2010, and two data which is coming in 2011. So okay, that should be fine. Now coming back in 2011, if we talk about so here I can able to see these two records here. So what is happening internally? Like if I give select star from dynamic underscore tab where yoj is equal to 2010. So what is happening? It will just go ahead with this directory or the directory data only. It will fetch the whole data from this directory only. It will never touch this 2009 and 2011. So what is happening? Whatever the records in 2011, 2009, we are not scanning that records, only scanning the 2010 records, whatever the data I need. So it will give a better performance as compared to earlier. So now we can see this data is there in 2010. That should be fine. That has been, we have achieved the expected results here. So this is the way we are using the partitioning till here. So now coming to bucketing, so we'll talk about the bucketing later because okay, so just to be, it is a also performance tuning in Hive, which is meant for data slicing mechanism. So it's also like as we have seen the partitioning in which we have partitioned the data here. So in bucketing, we are just it's kind of partitioning of the data only, but here we are slicing the data. Here it is not creating a directory; it will create a bucketed file. Okay, and it works on what we can say, which algorithm has partition algorithm. Yeah, has partition algorithm. It works on this algorithm. So we'll talk about this in briefly. What is the hash partition algorithm? How it will divide the results? How it will work? What is cluster by? So here we are using one of the class is known as cluster by. Instead of partition, we are using cluster by. So how this cluster by works here, we'll talk later. Let me go ahead to explain about this some advanced topics concept in Hive. Okay, so what is that? So as you are aware about order by, so what is that? Order by is known as for like any data which we are getting in RDBMS. I just want to get the data in terms of order by, so we have to use order by columns name. So, okay, that is fine. But what is the order by in Hive? So in terms of mapper and reducer, so irrespective, we can say irrespective of volume of data. Only one reducer used to sort. Okay, so whatever the huge volume of data we have, only one reducer will work here. You understand? So what about the order by? Like I have 10 petabyte, 20 petabyte, 30 petabytes have data, but irrespective of that data, it is not worrying about the volume. Only one reducer will work here to reduce the sorting the data. So as per the execution, it will work very slow as compared to sort by. So instead of sort by, it just depends upon data volume. It we can say generates reducers. Okay, so it depends upon the data, how much data it is there. Accordingly, it will generate the reducers there. So distributed by or cluster by, this is the class also. Distributed by means grouping. We are using this commands for grouping here. Okay, so like just give the command select star from some tables distributed by some columns like bank ID or something like that. So it's just like a distributed by means just grouping the with the help of the bank ID and will give the results. Instead of group by, you can use the distributed by here. What is cluster by? Cluster by is a combination of sort by and distributed by, we can say. Yeah, this is the combination of sort by and distributed by of the cluster. So this cluster by of the class, which we will discuss in bucketing in briefly. What is that? So now it's okay. There is no, right now we don't have any practical session for this because it's a very if interview will ask this question, somewhat they will ask what is the difference between order by and sort by. So you have to say like that. It irrespective of data, whatever the data volume we have, only one reducer will work there. It will take some time to sort the data. Whatever the data we have, it depends upon the reducer volume of data, and the reducer will generate there. So it's, you have to say like that. Okay, so now coming to some most important topic, like how to change the manage table to external table. Like by default, I have created manage table, but as per the client's requirement, he don't want to manage table. He wants the external table because some other things also there to work on that data. So how to change that things? So there is a mechanism like alter table name. Okay, set tbl properties. Sorry, properties. Table properties, yeah, that should be fine. And you have to in single quote external, because from internal to external I'm just changing. External is equal to true in caps, both should be in caps, we have to give. So this is the way I can change the manage table to external table. If it is an external table, I just want a manage table, what you have to give, instead of true you have to give false there. So it will create a manage table. So that's what, this is the way I can change the internal to external table. So let me go ahead and we'll see one of the examples here. So like right now, this is the table which is a managed table right now. Okay, so if you want to describe formatted, and we give dynamic underscore tab. Okay, so let me go ahead and we'll see what this. So right here is manage table. I'm just giving alter table name dynamic underscore tab, set tvl properties. Okay, and you have to give external is equal to true. Sorry, so I just want to give the external as a true. So again, I can, initially it is managed, right? Now I can see it becomes, okay, still it is managed. What the command I have given? Oh, sorry, true spelling is wrong. Yeah, so now it becomes like that. So now I have given the external. Now you can able to see from the manage it becomes to external table. So the team respective team will work on that. Like external teams can also uh, handle this data and all these things they can do from their end. So let me go ahead with the agenda. So till we have discussed whatever the topics we have discussed, except bucketing, we have not seen the practical sessions for the bucketing as of now. Except whatever the topics in Hive till we have done with hands-on as well. So one more topic we have, whatever I have left with you, transactional table. Transactional table. So what is happening in transactional table? See, there is no update and delete command work in Hive. Okay, so let me show you it work or not. Uh, I know I have data here, show tables. Okay, so I'm just giving select start from table temp underscore tab. This is a table which we have. I have this data. I just want to delete this record where id is equal to 1. Okay, I just want to delete this record. So how we can do these things? So let me check. So this is the command delete from temp underscore tab where id is equal to 1, right? Let me show you. So what he is saying, attempt to update or delete using transaction manager that does not support this operation, means in Hive, in Hive, because why the HDFS is the backbone, and on HDFS is immutable. It means we cannot override the data there. We cannot update the data there. We cannot delete the data there after write once, read many concepts is there in HDFS. So that's why they told like that this feature is not working anymore, update and delete. So how we can achieve this feature? With the help of this transactional table. So how to set up the transactional table, how to create it, how it works, and how to load the data, how we can update, how we can delete. These things we will see in next class. Before going ahead, like in the next sessions, what I'm going to start, one of the ETL tools known as Scoop. That is the ETL tools, okay, which is mainly meant for import and export data from RDBMS to HDFS, okay, and vice versa, we can say. Yeah, so this is the tools which we are going to learn in the next session. Inshallah, by next session I will cover these tools. Within 2 days I will complete it with the hands-on. It will not that much large topic. It is just import and export, but there's a lots of commands or two options here. We can go ahead and we can use each and every things. We will see accordingly. So before starting the scope, we will just have to see these two concepts. One is the transactional table and one is bucketing in Hive. I will show you the practical session on these two tables, on these two things. It will take around 15 minutes or 20 minutes, that much time. And after this, after this completion of this, I will start the scoop one of the ATL tools there. So let me pause the recording.